Good morning, everybody. I'm Alex, and today I'm going to tell you about EarthBound and its almost Turing-complete text system. So EarthBound is a video game that was released in the States in 1995 for the Super Nintendo, which was Nintendo's second big kind of console generation for the home. EarthBound is a role-playing game, and it is one of the most beloved role-playing games of all time. And I could talk for hours about how great this game is, but I'll have to just kind of cut myself short and say that in a lot of ways, despite being charming and whimsical and just a wonderful game, EarthBound looks a lot like a traditional role-playing game of that era. You control a protagonist whose name is Ness. Ness and his friends go on a quest through the world. They see interesting places and talk to interesting people. If you see up there in the upper right, it's talking to somebody. You also fight monsters, the combat system's down there on the right, and you get money from fighting monsters that you use to buy better weapons and armor to fight bigger monsters, and that's kind of the core mechanic of the game. So in a lot of ways, EarthBound looks like a traditional role-playing game, but there's one part of its internals that's really strange, and that's how it handles text. So you'll notice here there's a lot of text in these screenshots, and you interact with text a lot in a game like this. And in a lot of these sorts of systems, you're dealing with text as a very isolated little thing. It just draws some text on the screen. But EarthBound's text system is different. EarthBound's text system actually forms part of an interpreter that's effectively embedded into the game itself. And this interpreter has registers, it has an instruction set, it has a call stack. It's remarkably sophisticated for a game that had to fit on, I want to say, an 8-megabyte ROM cartridge. What's even cooler is that people on the internet have been looking at the guts of EarthBound and studying this interpreter and how it works now for almost 20 years. The work on this started in the very early 2000s. So today I'm going to tell you a little bit, kind of give you a whirlwind tour of how this little interpreter works. Let's start with the registers. So EarthBound's register set is very modest. It has 3 of them. There's a 4-byte working register that's usually used for storing return values. There's a 4-byte, the documentation calls it argumentary register, that's used to pass arguments. Typically, when you, later on when you see things that take a hex byte as input, if you set that byte to 0, a lot of these instructions will just read whatever the contents of the argument register are. And then you've got that's actually a typo, it's a 2-byte secondary register, and that's mostly used for loops, for counters. There are actually 2 sets of these 3 registers. There's an active set and a storage set, and there are special instructions in the ISA that will swap the active and storage sets between one another. So let's actually talk about that ISA a little bit. So I'm going to denote operations in EarthBound's instruction set in square brackets. These instructions consist of 2 parts. First part is an opcode. This is typically 1 byte, but it could be 2. That basically describes what operator you're dealing with at any given time. And the rest of these arguments, or these little numbers, are all the kind of operands of this operation. And this is a variable length instruction set, so different operators can have different numbers of arguments. So now let's do a whirlwind tour of a very small subset of the things that this interpreter knows how to do. Most simple thing is how to control text, right? So this is kind of what you would expect. You can make line breaks. You can stop parsing text so that you don't buffer overflow. You can halt the kind of display of text either with or without a little prompt. This is kind of the very, very basics that you would expect from a text system. Here's an example of what that looks like. You'll notice here there are 2 lines. That first line is terminated by a kind of a stop and a line break. But the stop has a prompt, so you can see when it loops again, little arrow down there. And the second thing stops parsing and terminates. So that's kind of the very basic thing you would want to do with a text box. You can also support pretty basic Boolean variables. So there's a collection of several hundred of these event flags. You can turn an event flag on, or you can turn it off. And then you can insert something into the text parsing routine that will jump to a particular location in the code if a particular event flag is high. And this is used for things like if you speak to somebody multiple times, the first time the event flag's off, the second time it's on, stuff like that. So you can do different responses depending on how many times you've talked to them. It also supports branches, and it supports jumping to a location and continuing parsing until you're told to stop with that stop operation. Or you can jump to a location, keep parsing until you stop, and then jump back to where you were and continue parsing. So in this way, what you have is effectively a call stack, right? Which is pretty cool. There's also a multi-address jump that you can have any one of a number. Well, not any one of a number. You can do up to 255 of these pointers. And based on the value of the working register, you effectively pick the pointer in the list to jump to and jump to it. There's also more kind of bizarre things, like controlling how battle works. So there's an instruction that will increase party member like X's HP by Y%, which is pretty good if a monster hits you and you have to take damage, or if you heal yourself and you gain life that way. You can also set a party member's level to whatever stats they should be at for a particular level in the same instruction set. And then you can display text graphics inside of the battle system. So for example, this code produces the smash icon. That's literally all it does. Now, another thing that this system controls is cutscenes. So if you wanted to do a cutscene, you want the kind of non-player characters to move around and do stuff. So the first thing you want to do is make sure that the player can't move. So there's a specific kind of operation in the instruction set to lock player movement. You can also take a given sprite out of, there are a couple of different tables that due to time I can't really go into. But those tables will give you kind of a lookup for what sprite you're talking about. And then there's also a table of movement patterns, which is like go this many pixels to the right and then turn and go this many pixels down and so forth. And you can assign movement patterns to sprites that way. Also, if you want a sprite to just stay in one place and turn direction, like you want somebody to look to the left and then look to the right, you can give them an instruction to change direction. And keep in mind, this is all with the same thing that does text and everything else. So then there's the truly like the kind of CISC-y part of the instruction set, right, which is the miscellaneous operations. So at some point in the game, you can buy a bicycle, which lets you kind of run around the world at a slightly faster speed. And also, he just looks so happy riding that bicycle, doesn't he? And there's a specific instruction to summon the bicycle. But you can't do it while wearing pajamas. So there's that. There's also a camera guy that occasionally kind of descends from the sky to take your party's picture and kind of gives you like a slideshow of pictures during the end credits. You can summon the camera guy with an instruction also. And you can teleport. And there's a pre-registered list of instructions that you can teleport to. Insert that instruction, and you teleport. So this is like a tenth of the instructions that we know about, and people are still studying the internals of this interpreter, trying to figure out what the rest of these things do. And this link is actually, they call it the control code lexicon. That's like the list of all the control codes we know about. Some of them are just like, we have no idea what the arguments for these are. So you might ask, why have people been looking at this game for so long, trying to figure out how the inside of it works? And the answer is that people have been using this game for a long time as the basis to make their own stuff. So there's a website called PKHack that will give you a bunch of patches that if you, through some means I can't for legal reasons, tell you acquire an EarthBound ROM, you can apply a patch to that EarthBound ROM to make it either change aspects of the game or to make it a completely different game. And if you're familiar with the game Undertale, apparently the guy that wrote Undertale's first game was a mod to EarthBound that he wrote when he was like 13, which I think is pretty cool. Also, people have made things that make this a little bit more palatable. There's a language called CCScript that compiles into this instruction set that you can use to drop, so basically drop in. And people have a whole bunch to copy paste thing earlier. There's a whole bunch of like little scriptlets that people have built that you can drop into your game. There's also a thing called Coilsnake that will let you edit just about everything in EarthBound, from the sprites to the maps. And it also has a CCScript dumper and a CCScript editor. And with that, that's about it. Thank you very much for listening. And this is my contact information. If you want to get a hold of me, I'd love to talk about this stuff more. Thank you very much.